Should that say it's recording?
Yeah, because that's a stop button.
Okay. So let's go ahead and get started. You are in your own notes. You're in your own notes. So most of what we're doing today, you did it at the very end of Algebra 2. Okay? Exponential and logarithmic functions. They were your favorite then. You're going to love them even more now. So 9-1, logarithmic and exponential functions. Okay? Logarithmic and exponential functions. So what do we know about the relationship between an exponential function and a logarithmic function?
They end in shoal.
What?
They end in shoal, as in T-I-A-L.
They do end in shoal. Okay. Anything more about the mathematical properties of exponential or logarithmic functions? They are blank of each other. Ooh, what do we say in math instead of opposite?
Inverse.
They're inverse functions. They're inverses of one another. So just like a quadratic function's inverse is a square root function, and just like a sine function's inverse is arc sine, they undo one another. Okay? So your essential question for today is, how can we transform logarithmic equations, and how can we evaluate logarithmic expressions? Okay, so we're going to be focusing mostly on that one. Your essential questions over on the side of the board as well. All right, so the relationship, we just talked about that. The relationship is that they are inverses of one another. Okay, and mathematically when we're writing them, b to the x equals a. What type of function is this? It's an exponential function. Why do we call this an exponential? It has an exponent, right? We're not trying to get crazy here. Mathematicians are not creative. Okay? What do we call this b right here? What? The base. Very good. So this is your base, this is your exponent, and this is what it equals. Okay? This is equivalent to log base b of a equaling x. This is how to go back and forth between a logarithmic function and an exponential function, and so and vice versa. Okay? Notice that the answer to a logarithmic function is the exponent. Okay, that's where a lot of you, I think, get kind of muddled around in your brains. The answer to a logarithmic function is an exponent. All right, so let's just jump right in here. If I were my favorite pen, where would I be? Okay, fine, whatever. All right, so let's do a couple of examples of these. Let's do a couple of examples. Example. We want to rewrite from the logarithmic form into exponential form. Okay, that's what we're wanting to do here. We want to take our logarithmic form and we're going to rewrite it into exponential form. So example 1. Let's say you were given log base 3 of 81 equals 4. Okay, you're given that logarithmic equation. Well, if I'm rewriting this right here back into an exponential function, what would my base be here? 3. And then what would be my exponent? 4. So 3 to the 4th power would equal 81. Is that true? 3 times 3. And then 3 times 3 again. 9. And what's 9 times 9? 81. 3 squared squared is 81. Okay? So, it is true. That's it. Oh, I can make it more difficult for you if you'd like. Okay, that's it. That's it.
If it's
Which,
more difficult than this, my ankles will get broken much more.
okay. This year, you're going to look back and say, why did I have a trouble with exponential and logarithmic functions? Okay, I think it's just because you were tired at the end of Algebra 2. If we're being really honest, you were done. Okay, you're done now. I can't see. Okay, so number 2. Log base 25, sorry, log base 25 of 5 equals 1/2. Log base 25 of 5 equals 1/2. So what would my base be? 25. What would my exponent be? And what does that equal? 5. Okay, y'all typically freak out with rational exponents, meaning fraction exponents. What was another way to think about anything to the 1/2 power? I haven't heard it yet. Square root, right? 25 to the 1/2 is exactly the same thing as the square root of 25. To the 1/2 power is square root. Let's just try another one, just for fun. And I think you should try this one, because it's so fun. Yes?
Would you take either?
I would take either.
Do you want these boxes?
I don't need them anymore, but Miss Clarkson or Miss Johnston will be moving soon, and they both need them. Miss Clarkson's across the hall, catty corner, and Miss Johnston's in somewhere down there.
Okay.
But they're both math teachers. Thank you, though. Right. Okay. I'm really good at giving it, directions. Okay, here we go. This is all you. Log base 8 of 4 equals 2/3. Log base 8 of 4 equals 2/3. You're just rewriting it. I see most pencils are done moving. So, you should have written 8 to the 2/3 power equals 4. Okay, if you did that correctly, that's what it should be. Now, as we do these, I'm going to review your exponent rules. So, to think of this, the top number is squaring it, or cubing it, or to the 4thing it. It's making the number bigger. The bottom number is the root. So the square root, or the cube root, or the 4th root. So here, you can think about this 2 different ways. What is 8 squared? Ooh, pumpkins. Let's try that again. What's 8 squared?
67.
Oh, be still my heart. Look at y'all knowing your exponents. Okay. Then what would be the cube root of 64? Meaning, what times itself 3 times gives you 64? 4 question mark. It's right there, pumpkins. Yes. 4 times 4. 16 times 4. 64. Whew, y'all gotta wake up. Okay. Now we can do it the other way. What is the cube root of 8? Meaning, what times itself 3 times gives you 8? 2. Then what would be 2 squared? 4. So it works either way. Yeah? Yeah. And you don't have to think about it? That's your favorite part? Okay. Okay. Example 2. Oh, well, the next type of examples. We want to rewrite from exponential form to logarithmic form. So let's see here. Example 4. Let's do 4 to the -3. And I'm not going to give you the answer yet because I don't want, to just spoil Brian's favorite part all at once. I want to make sure that he has time to enjoy his favorite part. Okay. 4 4 to the negative 3. What does that negative in the exponent do?
Makes an imaginary number.
Good guess. No. Does not make it negative. What's the answer here? Don't put it in your calculator because I'm going to tell you no. Huh?
Negative and positive.
Ooh, okay, so I'm hearing 64. Where are we getting the 64? 4 cubed, right? That negative. Nobody remembers this? What? No, okay. E for effort, okay.
I mean, it would be negative.
It would not be negative.
If it was negative for,
What? French?
Oh, that just hurt my head.
I still am not listening to you, I'm sorry.
if it was negative 4,
If it was negative 4,
it would be
it would be
negative 64.
it would be negative 64. Okay? Do we need to see why this is the case? I think I've showed y'all before. Yes, you do, Nay. It's good for you. It's so good for you. Okay, so over here, we can do it with fourths. That's fine. So we just determined that 4 to the third was 64. What is 4 squared? 16. What's 4 to the first power? 4. What is 4 to the 0 power? Oh, pumpkins. Anything to the 0 power is? Anything to the 0 power is?
1.
Oh, okay. Okay, I see you. Actually, I heard you. Anything to 0 power is 1. It doesn't matter what it is. Well, let's think about this. Using multiplication or division, how would I get from 64 to 16? Divide by 4. And then how would I get from 16 to 4? Okay, How would I get from 4 to 1? So, assuming that this pattern continues, because patterns typically do, what would be 1 divided by 4? 1 divided by 4. And then 1/16th, 1/64th, right? Like that, it doesn't mean that it's negative. What this exponent is saying is, when you're negative, you're down, right? You don't like what's happening in life. This 4 right here is down about being where it is. It would much rather be in the denominator. And as soon as you move it, it's positive. It's happy. Okay? Really kind of personifying exponents here. Okay, fine, Miss Cleveland. That works with 4s. That works with 4s. Does it work with anything else? What's your favorite small number, Nathaniel? 2, okay. What's 2 cubed? Oh, too long. What's 2 cubed? 8. 2 squared?
4.
2 to the first power?
2.
Don't let me down. 2 to the 0. Oh, yes. Yes. Air high fives. Okay, only one person. Good. Okay. What is 2 to the negative 1/2? 1/2. That 2 drops down. What is 2 to the negative okay. Why? Well, that's 1 over 2 squared, and 2 squared is 4. So that's 1/4.
Keep going, this is fine.
Okay, 2 to the negative 3. Ohms. For all of OMG. Ohms. Ohms. Okay. That will work with any number that you have. Okay. And that's also a very rudimentary proof of why anything to the 0 power is 1. Okay. Because we're dividing by 2, dividing by 2, dividing by 2, dividing by 2. Oh yeah, Miss Cleveland. You teach us all the cool things. Okay, so back to the original example. Before I got to bird walking. This would be log base 4, because that's the base, of 1 over 64 equals negative 3. Remember, the answer to a log is always an exponent. So that's how that would all fall into place there. I think we need to do another one. Yeah? Yeah. Cinco. I think y'all have jokes, don't y'all? And by y'all, Eric. 16 to the 3/4 equals 8. Well, let's double check that that's true. Do you want to cube 16 in your head? I love math, and I don't really want to either. But could I 4th root 16 easily in my head? What times itself 4 times gives you 16? 2. And then what's 2 cubed? Boom. Right? This is so much fun. I don't think I'm going to give you all y'all's calculators this unit.
What?
Why does that mean? Miss Cleveland, you mean I actually have to learn my math? That's so mean.
I'm gonna get the,
Alright, so what?
4 to the power of 0 on the test method.
Log base 16 of equals, oh yeah. Where did the 16 come from? That's the base.
Larger 16,
That's the base.
not smaller.
The exponent is always the answer, so these things kind of switch places. Okay? This is all you. This is all you. Okay, what's the hardest example I can think of? Oh, yeah. Miss Cleveland, I love pre-cal.
Perhaps that is correct.
All right, most pencils have stopped. You're either stuck or you're finished. Okay, so log base of equals, if these numbers match, this will always be 1. So if I did log base 100 of 100, 1. Log base 10 of 10, 1. Log base 25 of 25, 1.
Is this gonna be like, is it gonna get like harder than that? Or like not hard, but like.
Yeah. Yeah. Speaking of which, let's amp it up. I think y'all are ready. I think y'all are ready. You thought you were good? Let's get crazy. All right, solve.
Yes, the first.
And it all goes downhill.
That's the spirit. Solve. Okay, so it may be easier to rewrite these. So let's just do example 7 here. We want to solve for x. Log base, let's do 3 of x equals 4. Log base 3 of x equals 4. And some of you are like, Miss Cleveland, I don't need to rewrite this. I can do this in my head. That's fine, but don't mess up. Okay? I would much rather rewrite it and make sure I know what I'm doing. So, I think it's much easier, like I said, to rewrite this into exponential form. What's my base? 3. What comes next? What is the 4? It's an exponent. 3 to the 4th equals x. What is 3 to the 4th? This one y'all should know. 81. It is the first one we did, yes. You with me there?
So in order to solve these, you just convert to exponential.
What I would do. Okay, well, let's do another one then. Log base x of 243 equals 5. I highly recommend rewriting it into exponential. So what's my base? x. What's my exponent?
5.
And that equals 243. Okay, so automatically I'm thinking, I'm going to multiply something by itself 5 times, and that number is not that huge. So I'm going to start with something small. What's 2 to the 5th power? 32, so not big enough. Let's try 3 to the 5th power. What did we say 3 to the 4th was? What would 81 times 4 be? Or 81 times 3? 243. Boom. X equals trace. I would know 2, 3, and 4 up to the 6s. It'll just make your life easy.
So for these, just try to like take each number and then use the exponent and see if it gives you the what it is.
You said no to.
I would know 2, 3, and 4 up to like 5 or 6. What is 2 to the 5th? 32. What's 2 to the 5th? Let's get crazy. What's 2 to the 6th? 64. Good. Okay, good. What's 3 cubed?
27.
What's 3 to the 4th? What's 3 to the 5th?
2 to 43.
43. What's 4 cubed?
64.
What's 4 to the 4th?
256.
256. Very good. Way to use your calculators. Okay, so those, if you know them, it's a lot easier just to do it. Okay, this all you?
Oh, no.
Yeah, you got this, girl. Log base 0.1 of x equals 2. Stop freaking out. You've got this. I wouldn't give you anything that you couldn't handle.
Cleveland, that's what you've done all year.
Junior and senior pre-calculus students, you can square 0.1 without a calculator. And if you cannot, bless your hearts. I believe in you. Alright, what is the base? What is the exponent?
2.
Which equals x. Okay, well, 0.1 times 0.1, 0.01. Why it gets smaller? What happened? Okay, let's not use 0.1. Let's not use 0.1. Let's use 0.5. What is 0.5 equivalent to? Half. So you got a cake, and I'm going to give you half the cake. Okay? So when we multiply that by 0.5, what happened to that cake's size? Got smaller. Now you take that half that you have, and I tell you to half it again. How much is left? A quarter. So every time you multiply by a decimal that's smaller than 1, it's actually getting smaller. So this is the essential, this is taking a tenth of a tenth. Okay? Alright, let's do some more because this is so much fun. It's one word for it. What's another word you might use? That hurt. That hurt me right here. What's another word for that? Okay, good. Are we on example 10? Okay, let's get crazy. We're still solving.
Spare my sanity, please.
You didn't have any to begin with, Pumpkin. Shots fired, Miss Cleveland. We are still solving. Yeah, just be cool, Flaccasicles, be cool. Here we go. Name the movie.
Top Gun.
Be cool, Flaccasicles, be cool.
21 Jump Street. 22 Jump Street.
Samuel L. Jackson, John Travolta.
Pulp Fiction.
Very good. Okay. So, stay with me, if these two things are equal, and they are because I'm telling you that they are, and their bases are the same, What has to be true about their exponents?
They're the same.
So I don't care what the base is. If the bases are the same, the exponents have to be the same if these are equal. So I can simply set the exponents equal to one another and solve a good old two-step algebra problem. Subtract a 2, so I have 3x equals 1. Divide both sides by 3. I have x is equal to 1/3. As Toto. Okay. Let's drop this back in here. What's 3 times a third?
1.
What's 1 plus 2?
3.
Does e cubed equal e cubed? Boom. Okay, so see, this is a little bit harder than what we were doing, but this is still totally doable. Let's try another one. This will be fun. 3x plus 1 is equal to 27. We are not going to talk about the speed of light or relativity in pre-calculus. All right, so Miss Cleveland, it worked where we could just set the exponents equal to one another because these bases were the same, but now the bases are no longer the same. What do? Well, you make the bases be the same. You say, oh no, you're going to be the same. So typically you're taking your you're taking your larger number and making it have the same base as your smaller number. So how can I rewrite 27 so that it's a power of 3? 3 cubed. Is 3 cubed 27? So all I did was rewrite 27 as a power of 3. And look, now they have the same base. You always want to pick this base. If you pick anything else, it's not useful. Okay? So now that these have the same base, for these to be equal, what has to be true about their exponents? They have to be equal. So I can say x plus 1 is equal to 3. Subtract a 1 from both sides. X equals 2. Well, Miss Cleveland, I didn't have to do all that work to get there. That's fine. I'm showing the process so that when it gets harder, you know how to do it. Plug it back in. What's 2 plus 1? 3 cubed. 27. I thought so. Thank you. Yes, check plus. Negative. 1 more. The worst I could tell you is no. All right. This is all you. 16 equals 2 to the x minus 3. 16 equals 2 to the x minus 3. As it's written, can you solve it? No, you've got to do a little bit of work. If you did this correctly, you should be getting 7. Good job. I see still pencils, so you got it, or you're stuck. So, this doesn't work as of now because these bases don't match. So what I need to try to do is rewrite 16 as a power of 2. What is 16 as a power of 2? 2 to the 4th power would give you 16. Now the bases are equal, so if these two things are equal, their exponents also have to be equal. So 4 is equal to x minus 3. Add 3 to both sides. X equals 7. On a scale from 1 to 4, 1, I don't even know what language you're speaking. 2, it makes sense as long as you're doing it, but by myself I can't do it yet. 3, I can do this independently. 4, I could help someone do this. I could teach somebody. Where are we at? Okay, all right. Okay, cool. Let's make it slightly harder. Just for funsies. Example 13. Log base 5 of 125 equals x plus 4. Well, Ms. Cleveland, I can do this one in my head too. Let's work through the process so that when it gets more difficult, you know what you're doing. Some of y'all are looking around like, I could not do this in my head. That's okay too. Alright, so here, I always think it's easier to rewrite into exponential form. What would my base be? 5. What would my exponent be? X plus 4. And that's equal to, well, now we're back to exactly the same problems we were just doing.
So we just turn into exponential form.
Always. Okay? So I need to rewrite this so that they have the same base. So this is 5 to the x plus 4 is equal to 5.
Third.
What is it? I heard a couple different answers.
Third.
Cubed. Very good. Well, now that my bases are the same, x plus 4 equals 3. Subtract 4 from both sides, x equals -1. I always like to go back and plug it in. What is -1 plus 4? What's 5 cubed? 125. Boom. Worked. I'm going to have you try one all by yourself, and then we should be good to go. 14. Log base 6 of 36 is equal to 4x minus 2. Try that one. Log base 6 of 36 is equal to 4x minus 2. You should get x equals 1. Your homework is on Canvas. Just, you can turn the page in your notes and do it right there if you would like to, okay? Homework is in Canvas. It's already up there, 9-1 homework. If you still need to turn in your review or any of that, you can bring it next time. You can bring it next time. It's up to you. Tests? Ooh, I don't know. No, I don't want anything into, no. No review? No. I'll just do it next time. I just don't want it because then
You said you'll do it next time, but could you
What?
check mine right now?
Everything can come in next time. I'm sorry?
Could you check mine right now?